In the vibrant Pearl River Delta, a region synonymous with economic dynamism and rapid growth, a colossal challenge once stood: fragmented connectivity. For decades, the journey between Hong Kong, Zhuhai, and Macau was a logistical puzzle, often consuming hours. The vision was audacious: to bridge these major economic hubs across 34 miles of open sea, transforming commutes and fostering unprecedented integration. This was not merely about building a bridge, it was about forging a new artery for a burgeoning megalopolis, a testament to human ingenuity against nature's might. The South China Sea presents an unforgiving environment for construction. The chosen path for the bridge lay across waters prone to powerful typhoons, often bringing waves up to 10 meters high, alongside complex geological conditions beneath the seabed. Furthermore, the region is seismically active, requiring a structure capable of withstanding significant tremors. These extreme marine conditions dictated an entirely new approach to engineering and construction, pushing the boundaries of what was thought possible, demanding innovative solutions at every turn. From conception to completion, the Hong Kong-Zhuhai-Macau Bridge project represented a colossal financial undertaking. The estimated cost soared to approximately $20 billion, a figure that reflects not just the sheer scale but also the complexity and cutting-edge technology deployed. This unprecedented investment funded thousands of specialized engineers and laborers, vast quantities of materials, and bespoke machinery developed specifically for this unique challenge. It was a commitment by multiple governments and private entities, betting on the transformative power of connectivity. The bridge is not a monolithic structure but an intricate system designed to navigate shipping lanes in sensitive ecosystems. It comprises 3 main cable-stayed bridges, a 4.2-mile undersea tunnel, and 2 artificial islands that serve as transition points. This multi-component design was crucial for addressing the diverse environmental and logistical demands of the Pearl River estuary, including preserving the busy shipping routes that crisscross the region and minimizing ecological impact on local marine life. Each segment was meticulously planned to integrate seamlessly. A critical innovation was the 4.2-mile immersed tube tunnel, plunging over 40 meters below sea level to allow continuous passage for large container ships. Constructing this required prefabricating 33 giant tunnel sections, each weighing up to 80,000 tons, on land. These colossal elements were then towed to sea, carefully submerged, and precisely joined together on the seabed. This technique minimized disruption to shipping lanes and environmental impact during construction, representing a world first in terms of scale and complexity for such a deep and long immersed tunnel. To link the tunnel with the bridge sections, 2 artificial islands were meticulously constructed. These islands, one off Zhuhai and one off Hong Kong, serve as critical transition zones, housing customs checkpoints, administrative facilities, and ventilation shafts for the tunnel. Building them in deep, active shipping waters required groundbreaking reclamation techniques. Giant steel cylinders, up to 55 meters in diameter, were driven into the seabed, forming a watertight cofferdam that allowed the islands to be filled and constructed with unprecedented speed and efficiency. The journey from concept to completion spanned nearly a decade. Initial feasibility studies began in 2004, with construction officially commencing in December 2009. The sheer scale and ambition meant a protracted timeline, fraught with design refinements, technological breakthroughs, and the constant navigation of environmental regulations. Each phase demanded meticulous planning and execution, evolving from groundbreaking designs to the final structural connections. It was a continuous cycle of problem-solving, innovation, and perseverance over 10 intense years. The construction phase was a continuous battle against formidable obstacles. The complex geology of the seabed required innovative piling techniques and foundation designs to ensure stability. Managing the logistics of transporting massive prefabricated sections, like the tunnel tubes and bridge segments, across busy shipping lanes demanded precision and careful coordination. Furthermore, ensuring environmental protection for the delicate marine ecosystem, particularly the endangered Chinese white dolphins, added another layer of complexity, mandating strict protocols and monitoring throughout the project. The $20 billion cost wasn't a singular lump sum but a careful allocation across various critical areas. A significant portion went into the advanced materials required to withstand the harsh marine environment, such as corrosion-resistant steel and high-performance concrete. Specialized machinery, including custom-built vessels for tunnel placement and massive crane barges, accounted for another substantial share. Labor costs for thousands of skilled engineers, technicians, and construction workers over a decade also contributed significantly. This financial breakdown underscores the project's complexity and its reliance on cutting-edge resources. One of the project's most defining innovations was its extensive use of prefabrication. Instead of constructing large sections entirely offshore, which would be slower and more hazardous, huge bridge decks, tunnel elements, and even parts of the artificial islands were built in controlled environments on land. This strategy not only ensured higher quality and consistency but also significantly reduced the time spent working in the challenging open sea conditions. It was a logistical masterpiece, transforming the construction process into a precisely choreographed assembly operation. The final structural connections, particularly the joining of the tunnel sections and the bridge decks, represented some of the most critical and delicate phases. These operations often occurred in adverse weather, demanding extraordinary precision from engineers and construction teams. Underwater surveys, GPS positioning systems, and specialized joining mechanisms were employed to ensure perfect alignment and structural integrity. The successful completion of these connections signified not just a physical linking but the triumph of human collaboration and technological prowess against immense natural forces. After years of relentless effort and an investment of $20 billion, the Hong Kong-Zhuhai-Macau Bridge officially opened to traffic in October 2018. The inauguration marked a momentous occasion, not just for the participating cities but for the broader region. It symbolized a new era of connectivity and economic integration, promising to unlock further potential in one of the world's most dynamic economic zones. The opening ceremony was a global statement of engineering ambition realized. The most immediate and tangible impact of the HZMB was the dramatic reduction in travel times. What once took up to 4 hours by ferry or a circuitous drive, now takes a mere 30 minutes by car. This transformation fundamentally reshaped the logistical landscape for residents and businesses alike, drastically easing the movement of people and goods. It's a change that fosters greater economic efficiency, encouraging more frequent interactions and strengthening the ties between the three regions, making daily commutes and trade far more feasible. Beyond travel times, the bridge acts as a catalyst for deeper economic integration across the Pearl River Delta. By facilitating faster movement of goods and people, it lowers transportation costs and streamlines supply chains, benefiting industries from manufacturing to tourism. It makes the entire region more attractive for investment and business expansion, fostering a truly interconnected economic zone. This enhanced connectivity aims to unlock new synergies, driving growth, and creating opportunities for millions of people. A project of this magnitude inevitably raised environmental concerns, particularly regarding the fragile marine ecosystem and the endangered Chinese white dolphins. To mitigate this, extensive measures were implemented throughout the construction and operational phases. These included strict controls on dredging, noise pollution, and waste disposal. Specially designed migration channels were considered, and long-term monitoring programs were put in place to assess the bridge's ongoing impact, aiming for a delicate balance between development and conservation. While the bridge's engineering success is undeniable, its operational phase has faced its own set of challenges. Initial usage rates were lower than projected, partly due to complex cross-border permit requirements and the availability of alternative transport. Integrating different legal and administrative systems across Hong Kong, Zhuhai, and Macau required careful navigation. However, as procedures become more streamlined and the benefits of seamless connectivity become more widely recognized, traffic volumes are steadily increasing, gradually fulfilling its designed purpose. The Hong Kong-Zhuhai-Macau Bridge stands as a powerful symbol of modern engineering's capabilities. It demonstrates how, with sufficient vision, investment, and innovative problem-solving, even the most daunting natural barriers can be overcome. Its construction pushed the limits of design, materials science, and project management, setting new benchmarks for mega infrastructure projects globally. It is a monument not just to concrete and steel, but to human ambition, perseverance, and the relentless pursuit of progress. The world watches, learning from this extraordinary achievement. As the HZMB continues to mature, its full potential is still unfolding. It is expected to further enhance the Greater Bay Area Initiative, integrating a colossal economic zone that rivals major global economies. The bridge's legacy extends beyond its immediate utility. It serves as a living laboratory for future marine infrastructure projects, showcasing methods for resilience, environmental stewardship, and inter-regional cooperation. It redefines what is possible, inspiring future generations of engineers to dream even bigger, connecting communities and economies on an unprecedented scale.